Okay, so you ready? Are you ready? Are you ready?
Yeah.
Okay, so here's how you do this. You divide every term by the highest power of x in the problem. What's the highest power of x in the problem? No. Right, because it's x squared, right, but it's underneath the square root, so the x squared is really the x. But when we divide this stuff underneath the square root, we're actually going to divide it by x squared. So we're going to divide this by x squared, which is really dividing by x. When I'm dividing by x squared underneath the square root, I'm really dividing by x. Okay? So I'm going to divide this by x squared, I'm going to divide this by x, and I'm going to divide this by x. No.
Also, if we divide both of axes.
Right. Yeah, exactly. As long as you do the same thing to the top and the bottom, you're good. Okay? So, the x squareds cancel. So that's going to be the square root of 9 plus 2 over x squared over the x's cancel. 4 plus 3 over x.
Why can't we do 3x plus
Square root of 2 or something? That's not how square roots work. Because you're asking me, you're saying, is the square root of 9, let's see if this will work, plus 4. You want to say, well, the square root of 9 is 3, and the square root of 4 is 2, so that equals 5. That's what you're trying to do, right? But the square root of 9 plus 4 is the square root of 13, which is definitely not 5. You can't do square roots turn by turn like that. So now it's easy, because we want the limit as x approaches infinity, yes? So if you put in infinity in here, what's 2 over infinity squared? Really small, yeah, 0. So that's gone. If you put infinity here, what's 3 over infinity? 0. Okay, now, Matthew, that this term is gone, square root of 9 is 3 over 4, so that's my limit. Or, if you're watching Mean Girls, the answer is the limit does not exist. Have you ever seen Mean Girls?
Yeah. I've seen Mean Girls.
At the very end, and that's a good joke for today because they're all that mathy things.
I've seen it. Sorry.
You haven't seen it? Well, no, you don't get to
He gets to listen to the radio for birthday.
Like FM radio?
Yeah.
Nice.
Wow.
That's awesome.
People are sick.
Did Dad say anything when you used this and that?
No, but I looked up to him on Dexter and he just changed his head.
What happened?
Pointed it quickly.
What happened?
His bat is deader than
We're gonna get new cleats and get a new bag.
mine would ever show up to school.
The haircut? All right, number 10. Let the first quadrant region enclosed by the graph of y equals 1 over x. Please tell me you can picture the graph of y equals 1 over x in your head. Close. Not a chance. Not a chance. Okay. You have to go the other way. Jimson. And the lines x equal 1 and x equal 4 be the base of a solid. So here is x equals 1 probably, and here is x equals 4. So this is the base of our solid right there. Okay? So that means that we have something sticking out towards us from the screen. If cross-sections perpendicular to the x-axis are semicircles, so these are little semicircular cross-sectional. Actually, pretty big drawings. You see the semicircles coming out at you?
Yeah.
Okay.
It's popping right off.
The volume of the solid is. They're popping right off the screen. That's exactly right. So we're going antiderivative. Here's the easy part. From where to where? 1 to 4. Okay? Here's the hard part.
Oh, okay,
Okay, it's got it. The cross sections are semicircles, right?
And where do we get to take this test at?
Pi r squared.
Where do we take this test at?
Okay, the cross sections are semicircles. What's the area of a semicircle? Pi r squared over 2. So all we need to do is figure out how you would figure out what the radius of those semicircles are. They're semicircles, so I would be going, change colors here. My radius would go from the middle here to the side. So how would I find this distance right here? Let's do, so for this point right there, x is 1, this is the graph of y equals 1 over x. What are the coordinates of that point? Right here. 1, comma, 1. You put 1 in there for x, 1 divided by 1 is 1. So what would the radius right here be?
0.5.
It'd be 0.5. Okay, let's go over to here where x equals 4. So the coordinates of this point would be 4, comma, what? 0.25. So what would this radius right there be? 0.125, yeah, because it's half of the 0.25, right? Okay. So then the question is, what are the coordinates of this point right here? X, comma, what?
X over 2.
1 over x, yeah, because the way we were getting these y's is by taking the x's and plugging it in there, right? So if the y coordinate of this is 1 over x, what would be the length of that radius? Right, 1 over x divided by 2, which is the same as 1 over x times a half, so it's 1 over 2x. Okay? So over here, the thing is going to become pi times 1 over 2x squared divided by 2. So, yeah, let's simplify that a little bit. Pi times 1 over 4x squared divided by 2, but divided by 2 just like we did over here is the same as times 1/2, right? So my final answer for the area of those cross sections is pi over 8x squared. Like that. Okay? So if find the antiderivative of that. Oh, it's fine. So I got 1 to 4 pi over 8x squared dx. So you pull out a pi over 8. That's a constant, nobody cares. Rewrite the x squared as x to the negative 2.
X to the negative 3 over 3. So x to
Wrong.
the negative 1 over negative 1.
Right, so this is going to be pi over 8 times x to the negative 1 over negative 1, evaluated from 4 to 1. Okay? Can we simplify that at all before we plug in stuff?
I don't know.
How's it
Graphical flash, I don't know.
Huh?
It's like,
X to the negative 1 does what?
1 over x.
1 over x, so the x is going to go to the bottom, and then the negative 1 on the bottom just does what? Makes it negative, so really this is negative pi over 8x from 4 to 1. Okay? So if you plug in 4, you get negative pi over 32 minus, if you plug in 1, you get negative pi over 8. Negatives cancel. Negative pi over 32 plus, what's that going to be, what? 4 pi over 32. Who weighed in there? Was that me? Nice. So that equals what?
3 pi over 32.
35/36,
Which would be.
which is B. Is that a challenging problem?
Yes, it is.
Oh, yeah.
Will that be on there?
It's possible, and what you guys need to do, because it is a time test, so for the first section, you get 55 minutes. Yeah, do the ones you know, go through all the easy ones first, and then go through and see what you can get.
What's this time test for?
What I'm gonna do is we're gonna start next week where you guys are actually like kind of doing these in class, and then we're gonna grade them together. And then we'll see how
They
this
count as
works.
assignments.
Yeah, you want to count as
Yeah, but like, yeah, I said.
We need to
well,
grade
like-
go up, but like in class, like I'm gonna say, okay,
Yeah.
half an hour and work on this, and then we're gonna go through.
Well, you have to get up to the times.
What's that?
You have to get up to the times.
Okay, we'll see what we can do. I'll have my people talk to your people, we'll set up a meeting, see what we can do.
Is this like a type of test where you're like
It's just like
it's like a frickin' ACT?
Yeah, probably. So you just have to grab what you can. All right, so number 11, we have f of x equals natural log of x plus e to the -1. Which of the following is true at x equals 1? So we've got,
Yes, that equals 0.
is that what equals 0?
The derivative.
The derivative.
Yeah.
Yeah, so what's the derivative of natural log of x? 1 over x. What's the derivative of e to the negative x?
Negative e to the negative x.
Negative e to the negative x. Okay, so now we're not actually going to set it equal to 0 because they gave us a value for that. So if I want to know if f is increasing, I'm going to figure out what f prime of 1 is. What's f prime of 1? 1 minus, well, we got no calculators.
Fail.
26?
0.
What's e?
2.17.
Just say 0.
So 1 over e to the 1, right? Right? So that's going to be 1 minus, is this bigger or smaller than 1? What? Smaller. I mean, 1.27, so about 1/2-ish. Okay, so this is about approximately 1/2. So what's true about the function at that point if you get 1/2? It is increasing because the value of the derivative is positive. So I don't know which one that is.
Say.
It's what?
Okay.
Okay. Huh? Yeah, pick that up. Okay. Number 12.
How many problems are there in this whole thing? Is this like this whole book, the test? No, there's two.
Like, I'm gonna put the exam 3.
Yeah, there's like 6 of them in here. Okay, so I went to the AP thing one time and they said this is a classic problem that most AP kids miss on the test.
You just sort of
Almost. You know that the derivative and antiderivative are inverses of each other, right? So we did these at the very beginning when we were working with antiderivatives. The derivative and the antiderivative would cancel, but since this is an x squared, you would have to plug an x squared in there instead of a t. So this would be 1 over t plus x squared to the third. Okay? Most calculus students get that, and we plug in -1. But what people miss is you have to go chain rule. So you have to multiply this by the derivative of the x squared there. Yeah, that's when we're taking, and that's kind of hard to like explain how that all works. So this is what you plug -1 into. Yeah, give me some funny looks. That's important.
That,
because here's why. Let's say we're going to do the antiderivative of, we're going to do this first, right? Okay, so the antiderivative of that would be, you want to actually like figure out what it is, or let's not figure out what it is. Let's say the antiderivative of this is some function. What do you want to call it? Give me like q. Okay. So the antiderivative, the integral from 0 to x squared on 1 over 2 plus d cubed dt, we're going to say it's going to be something q, right? But we're going to evaluate it from 0 to x squared. So this would be q of x squared minus q of 0 would be my final answer, right? Maybe this isn't going to work. Maybe I actually have to do that. We might have to actually do the thing. Let's do the antiderivative. Let's figure it out. It's okay. We got it. These guys don't care. They're thinking about baseball right now.
I got negative 2/3.
So what's the antiderivative of 1 over 2 plus t cubed?
I thought we don't have to.
Oh, no, you don't. We can't even do that either. Shoot. Okay, so this is a really bad example of trying to explain. Okay, so let's go back to what I have.
Okay, but the way we really have to be answered, or can be answered, is just doing that one and plugging negative.
Yeah. Let's see if this will work. Okay, so this would be my answer to this, right? Maybe this will work, okay? So now if I want to find the derivative, I have to take the derivative of this, right? Okay, so that would be, the derivative of this is going to be q prime of x squared, right?
Yeah.
But then times the derivative of this right here. Because you have to do the inside out thing, the chain rule thing, okay? So that would be times 2x minus the derivative of this. But if I plug 0 in there, I'm just going to get a number. And the derivative of a number just cancels, so this is going to just be 0, okay? So the derivative of q, if since this is the antiderivative, the derivative q is going to be the original thing. Is this working kind of? Okay. So that means I have to take x squared and plug it into the original thing. So that's 1 over 2 plus x squared to the third, but then times the derivative of the stuff inside, which is a 2x.
Why do we use Q?
Kind of? Okay. Okay.
Why do we use Q?
Because he picked it.
Oh.
Ask him.
I didn't know.
Why do you always have to fight?
He wants X, okay.
Whatever.
That's the only thing he,
Okay, so you have to put -1 into there.
come on.
So 1 over 2 plus -1 squared is 1. 1 to the third is also 1. Times 2 times -1 is -2. And so that is going to be -2/3, right? Is 1/3 an option? Yeah. So they're trying to trick you because, like I said, most calculus students forget to multiply by the derivative of the thing. No, I mean one of the multiple choice choices. Okay, so they're throwing that in there to try and, because people forget that. But the answer that we're really looking for is -2/3. Okay?
So anytime there's like a power of the x.
Yeah, anytime there's something more than just a plain old x, you have to use the chain rule. Because when Tyson and I were talking about here, if this was just a plain old x in here, and then we use the chain rule, the derivative of x would just be 1, so it wouldn't change it. Right? Okay?
What do you want?
What do you want? Like, philosophically speaking, what do you want?
In livestock.
Yeah. So I'm talking to Justine, not you guys.
What do you want, like?
Excitement.
Excitement. Oh. All right. Okay, number 13. What's the average mean value of 2t cubed minus 3t squared plus 4 over the interval -1?
Plug in all three numbers. Yeah, -1, 0,
You could
1.
do that, but it would be wrong.
Fine.
Okay, remember the mean value theorem? Apparently not.
It's D. because arrows in the middle, negative 1 to 1.
If we take the antiderivative from negative 1 to 1 of 2t cubed minus 3t squared plus 4, then that gives us the total value of the function from negative 1 to 1.
So do we have to
Okay.
do 1, 0, and thing?
No, we're going to do the antiderivative and plug it in. Okay? So if we go from negative 1 to 1 of this whole thing, again, that's the concept of the antiderivative, the integral, and that will give us the total value of the function from negative 1 to 1. Okay, so let's figure that out first. All right? So and they gave us easy numbers. What's the antiderivative of t?
T to the 4th over 2.
T to the 4th over 2 minus
T cubed.
t cubed plus 4t.
Why do they gotta use T for X?
Shad doesn't. These x's all left.
So 1 is going to be 1/2 minus 1 is 3/4. No, 3.5.
What? Okay.
So it's 1 plus 1.
Wait, if you plug in negative 1, you get 1/2 plus 1 minus 4, right? Which is a total of 1. Okay? So if the total value of the function from negative 1 to 1 is 1,
Divide by 3.
ooh, so close. Where'd you get 3 from? Oh, but they don't want to, you're not going negative 1, 0, 1, you're going, what's the distance between negative 1 and 1?
3.
No, from negative 1 to 1 is 2.
Oh, right.
Okay, gosh, thanks. So this is the total value right here. If you want the average value, you divide by the width of the thing, okay? And you get 1/2. which
That's
is
not a real answer.
The answer, so that is not a good thing.
So we suck.
Divided by 3, you get theory.
Which is not, so that's a plus right there, so that is actually going to be 6.
Divided by 2, answer is 3.
So did you get 6 when you did
Yes.
that? Have you done it yet?
Not for it.
I did something right.
Oh no.
I know you did.
How did for you? Okay, well, that's not very hard.
Yeah, it's 6.
Is it 6? So we should just. What was it? Negative 1.
So if we're already having this much trouble, we can't use kind
Ah.
of.
Okay, anyway, we got 6, it doesn't matter. No, we just made it just a simple.
And still,
Okay, we talked about 14 the other day. 14 gives you a little slope field.
That's a run.
Okay, there you go. Got a kid. So you
It's
kind
B.
of follow the little thing there, and it looks like it's starting at about 0, then going up, and then going back down, and then going back up. So.
Find that one first.
Hold on. Explain this to me.
Go to B.
Okay, well, what you're looking for is you're looking at the little slope field they have, and if you superimpose the graphs of A, B, C, D, and E on that slope field, which graph matches the way the little dot dash lines are. And since sine goes like that, and the little dash lines are going up and then down and then up, and then that means it's a good word. Huh?
B.
So it's B.
So,
Okay?
I need to learn what things look like for the older people.
The sine and cosine graphs, yes, you should know
sine
what those look
plus
like.
3 is 0, cosine 0.
Okay, going way back. Going deep. Flashback Friday. Woo, this is like September. This is like our very first chapter when we're talking about limits. Okay? This is the Fowler days.
Valley.
Doesn't
Forgot about
exist.
Valley.
Okay?
How's she doing?
It's 1 minus 1
She's
is
across
0.
the hall, Mr. Helmy's room. Go
Right
over
now?
and tell
1
her.
minus
howdy.
1 is 0. Doesn't
That's
exist.
impossible.
Yeah, you should. If you're really excited, I'm sure you can. Why are you saying it doesn't exist?
One minus one is zero.
Okay, right, so you got 0 over 0, so you can't do that. Okay, so when we did these, we had 3 ways to solve them. One was plug the number in directly, and then that's your answer, okay?
I like that.
Another way was to factor and cancel, and then plug it in, okay? And another way was graph it, but we can't graph it, we can't use calculators, so that's not gonna work. Unfortunately, since you plug it in and you get 0, that doesn't mean that the limit doesn't exist. That means we have to factor and cancel so that we can plug it in, okay? This is going to be a gross little one. I'm sure we did maybe only a couple of these. I'm going to multiply by the complex conjugate.
Oh, God.
Oh, wait, I did that wrong. That's not the complex conjugate.
X plus one.
It's negative square root of x minus 1. Okay? So we multiply by the complex conjugate to get things to cancel. Okay?
What if we just put x minus 1, like root x minus 1 times root x plus 1?
Ooh, loving it. And I think that's where we're going with
Oh,
this.
that's-
Yeah. But do you guys see what Tyson just said? He is saying that you could treat this as the difference of 2 squares if you think of it as the square root of x squared minus 1. Right?
Yeah.
Yeah, and then that will allow us to factor the bottom into root x minus 1 times root x plus 1, right? And then the root x minus 1s will cancel, so that leaves us with 1 over the square root of x plus 1. I like your way best. Okay, so that's the factor and cancel method, and now you can plug in 1, and what do you get? And then you get 1.5, yeah. Which I think that's where we would have ended up if we did this, but backwards. If you FOIL this out, I believe you get, what is that going to be? What's happened? Okay, never mind. We're being attacked by buzz dust.
Well, you gotta go back.
We gotta go back. What do you get if you FOIL that out? Negative x, the root x is canceled, so it's negative x plus 1, which is 1 minus x, so those are canceled, but it would be a negative, yeah, so it would work out the same way. I like your with that.
So big.
More intuitive.
I think back in September I thought
Okay. Back in September.
way figured that out.
Look, it's a gimme.
That's
Huh?
me.
All we have to do is take the derivative. It's a gimme. Easy stuff. 2.
Cosine.
We can take our note
Times
card.
sine.
What's the derivative of cosine?
So we're
Sine, negative sine.
Negative sine. Minus
2.
Sine of x
Cosine of x.
cosine of x.
Okay. So which one is that?
We're so C. No. Yes. No. Yes. E. No. It is E. No, it's not.
So
It's
this
E.
is negative 2 cosine of x, sine of x, right?
Indeed.
Yeah. Because these things are the same, so negative 2 and
No.
negative, they're like terms, right? So you can combine that to negative 4 cosine of x, sine of x, which is e.
Oh, we can't use our note cards?
Now use your note cards, no notes.
Now.
Don't you want us to get this math credit?
What?
You want us to get this math credit?
What did you say was something like that? I don't have any place to leave.
Don't you want us to get this math credit?
Of course.
We should slip some Ambien in the coffee or something. And just
What's that?
slip some Ambien in the
Lock the
coffee or
doors.
something. Are we still recording? No problem. She won't be watching.
It is viral.
Yeah, it goes viral.
What?
It's video.
Over 4,000 views, my channel total. All 50 states. Yeah,
I got like 500, 600 on one.
you did?
Yeah, I think probably I have.
Was it
1,000.
the JV basketball highlight film?
I think included the JV basketball highlight film and the look at me now video.
But,
We have
viral shape video.
that's Drew's. Drew
How
and
many did that have?
It's got running out.
You did that, you did.
Like 700, like.
Oh, you did actually that?
Yeah.
That's not bad.
Are you kidding me?
That big is bad.
It's because like the program we use, it's like really laggy when you play it on there, so you can't like time it up right, and then once you save it, and then like you look at it.
Okay, here's another gimme, if only you could use a calculator. Area underneath the graph, that says, that says antiderivative. Slope of the graph is derivative, area under is antiderivative.
That's what it said to me, it was screaming.
Okay.
Scratch the north.
And this would be one of those where if you are running out of time or you're not sure or whatever and you have a guess, you can narrow this down to A, B, or C pretty much for sure. Because you know the antiderivative of 1 over x is going to be natural log of x, so there's going to be a natural log in the computation. Okay?
X to the fourth.
Say again?
X to the fourth.
X to the 4th.
Well, that's 3x squared. Minus ln
I had no Casey was on that.
Graduate.
Wait, is she
Not
really?
kids, yeah.
No, she's not.
Ben?
But Ben's not Casey. No reason.
That's
Okay.
Just plug them in or what?
Yep, plug them in. So 2 to the 4th,
It's probably 32.
probably not.
24.
It would be 16 though.
I was looking at the things over here.
Whatever. 3x squared, if x is 2 is 12, minus natural log of 2, minus 1 plus 3 minus natural log of 1. Yes? Yes. 28 minus 4 is 24. Generally, okay, minus natural log of 2, final answer done, y.
C.
No,
You don't have to.
no, what's natural log of 1 though? Why did I leave that out?
0.
0, and this is saying e to the what power equals 1, we did this yesterday, and e to the 0 is 1, so natural log of 1 is 2, okay?
C, final answer.
C. Okay, one more, uno más.
Un más.
Uno más.
Plus C. Plus C,
Don't
everybody.
forget.
We didn't initiate you.
Okay,
There's no taking in after
there is no taking the antiderivative of that, no chance. U substitution. Okay? I'm gonna tell you right now, the du has to be on top, okay? So I cannot let u be x minus 2, because then the du is gonna end up being on the bottom. So I'm gonna let u equal x minus 1. Okay, whoops, I already have an issue, because I need to break this up.
du equals dx, guys.
I just broke it up into 2 fractions, okay? Because you just said that the u is the dx, right?
Du, the dx.
But I need, for this one right here, I need 2 dx, yes? So I just have to multiply by 2. So this becomes the antiderivative of 2u du, right? I feel bad. We were doing it wrong. How do I do this one? Monday. Class is dismissed.